In this video, we're going to be looking at multiplying and dividing integers and the rules that go along with those operations. So we will look at patterns, and then we'll talk about the integer rule for multiplying and dividing integers. So let's just look at one in context. One day the temperature in Bella Vista is 50 degrees at noon, and then the temperature drops. So dropping could represent subtraction there. Temperature drops 5 degrees per hour for 6 hours. So it dropped 5 degrees per hour for 6 hours. What's the final temperature? So we could use the subtraction piece to model that. We could say, let's add this drop of 5 degrees per 6 hours. Hours is not going to be negative. Degrees could be negative, but hours would not be negative, so that's why we see the -5 to represent that drop of 5 degrees. So when we compute that, we're going to get 6 groups of a -5. So that's going to be -30, and we would see that that temperature after 6 hours is now 20. So let's look at patterns with multiplying integers. So let's see the results of each of these, and we'll work our way this way with the patterns. So we've got 4 times 3, we see we get 12. 4 times 2, we get 8. 4 times 1, 4. 4 times 0 is 0. So I'll stop there, and we can see what happens as we're going. We're keeping the 4 constant, but we're dropping the second factor. So based on patterns, to multiply by -1, it has to continue dropping. 12, 8, 4, 0. It has to be -4 next. 4 times a -2. Well, that would have to continue to drop 4 more, which would be -8. So I'll stop right there, because what we have just established is that a positive number multiplied by a negative number equaled, notice, a negative. Up here at the front, or at the very top, when we were multiplying 4 times 3, 4 times 2, we were just establishing that positive times a positive equals a positive, and you knew that for many years through grade school up until algebra, that up until then, that's when this positive and negative starts to change. So positive times a negative is a negative, positive times a positive is a positive. So we're going to take that rule that we know, and we're going to look at another example. So the patterns that we noticed is that when we multiplied a positive times a negative number, we realized based on the patterns that we ended up with the negative. And that's the rules that we established. Now that we know that a positive times a negative is a negative, 5 times 4 is 20, so that would be -20. So if we just continue with our pattern and keep the -5 constant, and then we'll just continue to decrease this constant, notice that we will see a pattern of increasing. Actually, it's what happening is you're increasing by 5, -20 to -15 to -10. So -20, -15, it's increasing by 5. So what has to happen next based on the patterns is it has to continue to increase by 5. So what you get is a +5. And what you just established or showed or proved using patterns is that a negative multiplied by a negative equals a positive. And then if you just continued on, -2 times a -5, you see based on where we left off, that was 5, and it continued to increase, it has to be +10. So a negative times a negative is equal to a positive. Those are the patterns that we noticed. So far we have positive times a positive is equal to a positive. We have a positive times a negative, and we said that equaled a negative. And then we saw that we had a negative times a negative equals a positive. So knowing those rules, when we look at a string of numbers being multiplied, you want to think about, well, what will be the sign of the answer? I'm not worried about the numerical answer. So on this one, we've got negative 24, negative 32, and a positive 14. Notice that this negative times a negative would be a positive, and then this 14 is a positive, so the answer to that would be positive. But notice you have two negatives. That is an even number of negatives. And an even number of negatives resulted in a positive. Notice on number 2 you have an odd number of negatives. And so if you take negative 5 times negative 6 times negative 3, this negative times a negative is a positive. That's a negative, so positive times a negative is a negative. And you had an odd number of negatives. Number 3, you've got 1, 2, 3, you've got 4 negatives, which is an even number, so that you know that answer is going to end up being positive. And then 4, you've got 1, 2, 3, 4, you've got 5, so you've got an odd number, so your answer sign will be negative. And then there's your rules based on odd and even number of negatives. So now let's look at divide. When we're dividing integers, we've got 6 divided by negative 2. What I want you to think about is that negative 2 multiplied by something is equal to 6. So what that gives you is that gives you an idea that this is a negative times something to equal a positive. And in order to kind of fill in there, that negative times, it has to be a negative to equal a positive. So 6 divided by 2 is 3, but it's 6 divided by negative 2, so it has to be negative 3. What about negative 15 divided by negative 3? Well, think negative 15 so think this, negative 3 multiplied by something has got to be a negative 15. So this is a negative multiplied by something to be a negative. And that's going to have to be a positive. A negative times a positive, or a positive times a negative, will equal a negative. So negative 15 divided by negative 3 should be a positive 5. Got 42 divided by negative 6. So again, you're thinking negative 6 times something is equal to positive 42. And so since this is a negative multiplied by something to be a positive, that answer has to be negative. So that would be a negative 7. So 42 divided by negative 6 would equal negative 7. And then negative 45 divided by negative 9 equals something. So you're thinking negative 9 multiplied by something would be negative 45. And so this is a negative multiplied by something to be a negative. And so a negative times multiplied by a positive would be a negative. So this is negative 45 divided by negative 9 would be a positive 5. So let's try 36 divided by negative 6. So I'm thinking a positive divided by a negative, and that's going to have to be a negative, because you're thinking negative 6 multiplied by something to equal a positive 36. And so negative times, and it's going to have to be a negative to equal the positive 36. And then second, you've got negative 35 divided by negative 5, and you're trying to figure out what that would equal. So negative 35 divided by negative 5, we know it's going to equal something. So again, you're thinking negative 5 multiplied by something to equal a negative. So that has to be a positive, or a positive 7, sorry. So negative 5 multiplied by a positive 7 would give you your negative answer. So what I want to look at is just how consistent or how extremely similar these rules are, just minus the different operation. So when we're thinking about multiplying and we're thinking about dividing, so a positive multiplied by a positive, you know you're going to get a positive. Positive multiplied by a negative, you're going to get a negative. And then a negative multiplied by negative will be a positive. So notice the only time you are getting a negative answer is when there's an odd number of negatives. And that's going to be the same thing with division. A positive divided by a positive will equal positive. A positive divided by a negative, or a negative divided by a positive, you can flip those around, is going to be a negative. So notice how consistent these are, how consistent they are here. And then you've got a negative divided by a negative, and that will be a positive. So the only time when you were looking at two numbers, when we're multiplying or dividing, if we've got an odd number of negatives, we're going to get a negative.